If you're anything like me, or even most people, then you probably don't think about physics class very much in your average day. But the truth is, physics is everywhere, in everything. Whether you're walking home from school or watching TV, playing football, you're watching physics take place. That's why knowing a lot about physics can get you out of a lot of scrapes. Let's say, for example, you're walking home from school one day and you get mugged. Remembering what you learned in physics class could just save your life. One of the equations that you learned in physics class that is often applicable in everyday life is the equation for force. Force equals mass times acceleration. If you get attacked, that equation is going to turn up all the time. Let's say you go to punch your attacker in the face. In order to knock out your opponent, you're going to have to apply a lot of force with your punch. That force will be the product of your fist's mass and its acceleration. In order to demonstrate this, I'm going to pretend that a wooden board is my attacker's face, and I'm going to see how much force I need to apply. This is the wood I'll be using, pine. Now, pine is a strong wood, so I'm only going to use 2 boards instead of the typical 3 or 4, and I'll see if that makes a good example of a person's face. So that was a fairly easy break, but I only just broke the boards, so I think it's safe to say that I applied the exact amount of force required to break them. Now, what I want to know is how much force that is. Well, I know my hand is about 250 grams, and I add another 150 grams to that value because a good Taekwondoist uses a large portion of their own body weight to punch, and I know that it covered 60 centimeters in about a quarter of a second. So now I simply multiply these values to find the force I applied. So here's my equation. And then I input my values for mass and acceleration. And by multiplying these values, I find that this, by the way, is equivalent to what I just said before, 60 centimeters every quarter of a second. So now I input these values to multiply these values to find that I applied 960 newtons of force with my punch. Now that's great to know, but a good Taekwondoist will not just want to know what happened during the punch, but what happened after the punch. So they'd give themselves a situation like, say, alright, so you just punched this guy. But there's another guy standing 1 meter away from him who's 2 meters tall. Does he hit the man? Now, to solve this equation, to solve this problem, I'm going to use one of the kinematic equations, that distance equals 1/2 acceleration times time squared plus velocity original times time. And to solve that equation, I'm going to use a method where I break it into 2 problems, an X and a Y plane. Now, I'm going to write that now into 2 equations. That distance in the X direction equals 1/2 acceleration X times time squared plus velocity original in the X direction times time, and that distance in the Y direction equals 1/2 acceleration in the Y direction times time squared plus velocity original times time. Now, to solve this equation, let me just think what I'm given here. Well, I know that distance in the X direction is 1 meter.
I don't know what distance in the y direction is, solving for that. I know that acceleration in the x direction is 0 because gravity in this case does not pull you to the side. I know that acceleration in the y direction is the acceleration of gravity, negative 9.8 meters per second squared. I know that my velocity in the x direction is 2.4 meters per second. And I know that my velocity in the y direction is 0 because I'm punching straight forward, not an uppercut or punching the person down toward the ground. And I also don't know time. Solving for that as well. So now I'm going to start by solving for time here. So I just input my values, whatever I have, to find what's left. Distance in the x direction is 1 meter, which equals 1/2 of axt squared, but since acceleration in the x direction is 0, I can just write that whole thing as 0. Plus velocity in the x direction, 2.4 meters per second, which is the same here because it's only 1 second as the acceleration. And I multiply that by time, whatever that is. And now I cancel out the 0, and I'm left with time, which is 0.416 seconds with a repeating 6. Now, since I have that, I can solve this equation on the y side using that. So now I just input what I have now. I don't know what distance in the y direction is, that's what I'm solving for, and input my other values. 1/2 acceleration, negative 9.8 meters per second squared, force of gravity, acceleration of gravity, and time, which I now know. And again, this cancels out because velocity in the y direction is 0. So I just cancel that out. And what I'm left with, by multiplying these together, is distance in the y direction, which is negative 2.0416 meters, again with repeating 6. Now, since that is a distance less than negative 2 meters, that means it falls more than 2 meters in the time that it takes to cover 1 meter. Therefore, he does not crash into the person.